All right, let's talk about it. You've just gotten a lab result back, and it has three little letters on it that can cause a whole lot of stress. A-N-A. So today, we're going to take that confusing piece of paper and turn it into something you can actually understand.
This is the big one, right? You see that word positive, your mind starts racing, you jump on the internet, which, let's be honest, is usually a bad idea. Well, the short answer is no. You absolutely should not panic, and we're about to walk through exactly why.
So here's our game plan. First, we'll cover what a positive ANA even means. Then we'll peek behind the curtain at how the test actually works. We'll decode the two big results, the titer and the pattern. Then we'll see what comes next and wrap it all up with why the big picture is everything. Okay, let's start our investigation. We need to meet the main character in this whole story, the anti-nuclear antibody. What is this thing and why are we even looking for it? You know, your body has this amazing security team called your immune system. Its job is to fight off bad guys like viruses. But every now and then, it kind of gets its wires crossed and makes something called an autoantibody. And ANAs, they're a specific type that have mistakenly flagged the command center of your own cells, the nucleus, as an enemy. And this is probably the single most important thing to get straight. A positive ANA test is not a diagnosis. Think of it more like a smoke alarm. When it goes off, it's telling you, hey, we should probably check this out. But it could be a real fire, or it could just be some burnt toast. It's a screening test, which means it's really good at flagging potential issues, but it's just the first step.
Okay, so the smoke alarm's ringing. But how does this alarm even work? Let's take a closer look at the test itself. Because when you understand how the lab finds these clues, the results start to make a lot more sense. This really breaks it down, doesn't it? On one side, you've got your normal antibodies, the good guys, the heroes of your immune system taking out real threats. On the other side, you have these autoantibodies, like ANAs. They've kind of gone rogue, and they're targeting your own healthy cells. The test we're talking about is designed to find those guys on the right. Now, the gold standard method has this long, fancy name: indirect immunofluorescence. But what it really boils down to is pretty cool. The lab takes a little bit of your blood serum and adds a fluorescent dye. If you have these ANAs, they'll latch on to the nucleus of some special cells on a slide and literally glow under a microscope. And from that glow, we get two huge clues to decode: the titer and the pattern. So let's tackle the first clue, the titer. If this is a detective story, the titer is all about the quantity of evidence. It basically answers the question, how much of this stuff is there? Now, on your lab report, you're going to see a result that looks like this, a ratio, something like 1 to 160. I know it looks a little weird, but trust me, the idea behind it is actually pretty simple. Here's an easy way to picture it. Imagine your blood serum is like a bucket of really dark, concentrated paint. The lab techs dilute it. They mix it with an equal part of solution, cutting it in half. Then they do it again and again and again. The titer is simply the last dilution where they could still see the glowing paint. So what does that actually mean for you? Well, it's pretty straightforward. The higher that second number, the more paint you had to begin with. As you can see here, a low titer, like 1 to 40, is often not a big deal. But as you start getting up to 1 to 160 or way up at 1 to 640, it becomes much more likely that your doctor's going to say, okay, we need to look into this further. All right, so that was the how much. Now let's talk about the second clue, which is all about the what kind. This is the staining pattern. And it's super cool. It's like the unique fingerprint the antibodies leave behind on the cell. What's so fascinating here is that these different fingerprints act like signposts for your doctor. I'm not going to read the whole chart, but just look at the variety. A smooth, homogeneous pattern might make a doctor think about lupus. A speckled pattern is super common and can be linked to a few different things. But then a centromere pattern? Wow, that's a very strong clue pointing toward a specific condition called scleroderma. It doesn't give the final diagnosis, but it helps the doctor know which road to go down next. So now our detective, your doctor, has two big clues in hand: the quantity from the titer and the fingerprint from the pattern. The general screening is over. Now it's time to follow the trail and get specific. Based on those first clues, your doctor can order much more targeted tests. For example, if the pattern and your symptoms point toward lupus, they might order an anti-dsDNA test. Think of that one as a potential smoking gun for lupus.
Or they could order something called an ENA panel, which is like sending out a search party for a whole group of specific antibodies. This is how you go from a general clue to a specific confirmation. This shows you the logical path your doctor is following. It doesn't just start with a random test. It starts with you, with your symptoms. That's step one. Then comes the ANA screening test. If that's positive, they look at the clues, maybe order more specific tests. And then, and this is the most important part, they put all the pieces together. And that brings us to the grand finale, the final verdict. Because after all the lab work and detective work, there's one thing that is more important than any single number or pattern, and that word is context. I'm going to say this again because it's so important. A positive ANA does not, on its own, equal autoimmune disease. In fact, get this, up to 15% of the completely healthy population can have a positive ANA, usually at a low level, with absolutely nothing wrong with them. Let's make this crystal clear with two quick stories. First up, we have a 24-year-old woman. She comes in with some very classic symptoms: a butterfly-shaped rash on her face, aching joints, and protein showing up in her urine. Her results come back. The ANA is positive at a really high titer, 1 to 640, with that homogeneous pattern. The specific follow-up test, anti-dsDNA, is also positive. In her context, with her obvious symptoms, that positive ANA is a critical piece of evidence pointing strongly toward a diagnosis of lupus. Okay, now let's completely flip the script. Case number 2. A 56-year-old man who just says he feels a bit tired. No other specific complaints. No rashes, no joint pain, nothing. And guess what? His ANA also comes back positive. But look closer. It's a very low titer, just 1 to 40. In his context, no specific symptoms and a low number, this positive result is almost certainly just a random benign finding. Nothing more to do. You see? The exact same word positive led to two completely different outcomes. So if you remembered just one thing, let it be this. An ANA test is just one tool in the toolbox. It's one clue in a much bigger investigation. The real answer comes from putting everything together: the titer, the pattern, the follow-up tests, and the most important piece of all, you, your symptoms, your story. A positive ANA isn't a verdict, it's simply the start of a conversation.